This is 4.4 Trig Functions of any angle. This is the first lesson in this section, and this is the last section before we take our unit test over sections 1 through 4 in Chapter 4. I want you to notice that there's the Cartesian plane here, and we also have a point located in the second quadrant with coordinates x and y. X and y. So if I go ahead and draw in, connect that dot, we're going to pretend that that is a straight line. A lot harder to do than it looks. There, it's slightly better. Then you could make a right triangle out of that. Okay, this is not a unit circle. So that means that this is the hypotenuse, this is the x-coordinate, and this is the y-coordinate. We also know this is quadrant 2, where x is negative and y is positive. All right, so those are just some of the things we know. So the first thing we want to do is note the quadrant of the terminating side of this angle. So if I draw in theta, theta would be from, of course, the x. This would be 0, right? And then this would be theta right here. I can find the length of h using the Pythagorean theorem. So h squared is going to be x squared plus y squared, and h, or the hypotenuse of that triangle, will just be the square root of x squared plus y squared. All right, so we have 3 sides of a triangle. We also know that the xy coordinates also correspond to the cosine of an angle. So the cosine of the angle would be the cosine of theta and the sine of theta. And we remember from the unit circle that this point right here, xy, corresponds to the cosine and the sine of that angle. Now, that brings up a reminder about the quadrants. Remember that sine is positive, cosine is positive, and tangent is also positive in the first quadrant. In the third quadrant, however, sine and cosine are both negative, so tangent's going to be positive, which looks like a plus, but that's tangent. In the second quadrant, we know that sine is positive, cosine is negative, so that makes tangent also negative. And in the fourth quadrant, where sine is negative, cosine is positive, and tangent's also negative. All right? So one way to remember this is all students take calculus. And that tells you which one is positive in that quadrant. So all students, all, meaning all of them are positive in the first quadrant. Students, only the sine is positive. Take, the tangent's positive in the third quadrant. And calculus, cosine, is the only one positive in here. So that's just a little mnemonic that they use to remember which one is positive. All students take calculus. All right, here's an example then of how you can find all 6 trig functions in terms of the given point. And the point here is -12, -5, which you can tell by looking. The very first thing that you're going to look at is you're going to determine what quadrant it's in. So we know that both of the x and the y coordinates are negative, so we're talking about the third quadrant. So this would be quadrant 3. All right, then the second thing we want to do is we want to find the hypotenuse of the triangle. And in a unit circle, that would be the radius. Okay, so for instance, this is the x-coordinate, this is the y-coordinate. So to find the hypotenuse, it's going to be the square root of x squared plus y squared. And you know when you square a number, you just get a positive. So I'm going to have 144 plus 25, which is the square root of 169, which is 13. All right, so I have all pieces now. I know that x is negative 12, I know that y is negative 5, and I know that the hypotenuse or the radius of the triangle is going to be 13. Okay, so then write the 6 ratios. So I have sine theta, cosine theta, tangent, cosecant, secant, and cotangent. All right. So I know that sine then is going to be y over h, so negative 5 over 13. The cosine is going to be x over h, which is negative 12 over 13. And the tangent is going to be 5 over 12, positive, because it's in the third quadrant. Okay. If I were drawing this out, it would look something like this, right? This would be the point, negative 12, negative 5. And my angle, this is theta. Actually, the whole thing is. And so then I have, this is negative 12, this is negative 5, and this is 13. And so what you're doing is you're just writing the ratios in terms of those sides. So cosecant is going to be negative 13 over 5. Secant is going to be negative 13 over 12. And cotangent is going to be, it's going to be 12 over 5. Okay, on this example, once again, they've given us more clues. Only this time, instead of writing all 6 trig functions, we just need to find the sine of theta and the secant of theta. All right? So the first thing we need to do, of course, is to find our quadrant. What quadrant are we in? So the first clue is that tangent is negative. And we remember that tangent is negative in the second quadrant and the fourth quadrant, where sine and cosine are opposite signs. So we've narrowed it down to 2. We need to narrow it all the way down to 1. So we look at the other clue that it gave us, which is that cosine theta is greater than 0. That means it's positive. So in which quadrant, 2 or 4, is cosine positive? And that would definitely be the fourth quadrant. All right, so we know what quadrant we're in. The next thing we need to do is draw a triangle. We know that the tangent of theta is 5 over 4. That's the ratio of opposite over adjacent. And then we need the third side. So when we find the third side, since these are both legs, I'm going to have 25 plus 16, which is the square root of 41. All right, so I know what quadrant I'm in. I know all 3 sides of a triangle. And so now I need to use that triangle to find sine theta and secant theta. Sine theta is going to be opposite over hypotenuse. The sine in the fourth quadrant is negative. So I'm going to have the sine of theta as negative 5 over the square root of 41. If I rationalize it, that'll be negative 5 square root of 41 over 41. The secant of theta, if you'll recall, secant is a reciprocal function. So if I have cosine, secant always goes with cosine. Cosine is adjacent over hypotenuse. Right? So that makes secant hypotenuse over adjacent. So that's going to be the square root of 41 over 4. And cosine is positive, so secant will be positive. And then we have our 2 answers. Right? So you need all of this to explain this problem. So once again, we have another set of clues, and we're going to write, instead of just 2 of the trig functions, we're going to write all 6. So first thing you have to figure out is what quadrant are you in. So if we know that tangent is less than 0, it means it's negative. So that will be either the second or the fourth quadrant. And cosine is positive again, so we're in the fourth quadrant. All right. The next thing we need to do is draw a triangle. Put in theta, and we have 8 over 17. To find the third side this time, I'm not going to add them together because I'm looking for the smaller side. So this would be 17 squared is equal to 8 squared plus y squared, right? And so I would have 17 squared minus 8 squared equals y squared. So what I'm looking for here is 17 squared minus 8 squared. Instead of plus, it's subtract, bigger minus smaller. And so that's going to equal 289 minus 64, which is 225, which is a perfect square, which is 15. All right, so this side here is 15. Now, we're in the fourth quadrant, so I'm going to go ahead and write all 6 of my trig functions. I don't know where I got 4. Cosine, tangent, cosecant, secant, cotangent. All right, and then this time what I'm going to do is I'm going to go ahead and put in my signs. I'll do them in red so I can see them. But in the fourth quadrant, sine is negative, so that means cosecant's negative. Tangent's negative, which means cotangent is negative. Cosine and secant are going to be positive. All right? And then once you have that, then you can go ahead and write in your values. So the cosine, I already know, is 8 over 17. So secant's going to be 17 over 8. Sine is going to be 15 over 17. And 17 over 15. And tangent's going to be 15 over 8, and then 8 over 15. And we're done. So you can kind of see the methods here. We're using puzzle pieces to figure out what information we have and then what we need to find. Okay, one more. And this one also gives us puzzle pieces. So once again, the first thing we want to try to figure out is what quadrant are we looking at. So we're looking at cotangent. We know cotangent is negative. Cotangent is a reciprocal function, so what other trig function that we use is going to also be negative? And that's going to be tangent. So once again, we're looking at second or fourth quadrant. That's this part right here. This part tells me that I'm dealing with the second or the fourth, and then I look at secant. Well, secant's also a reciprocal function. It's the reciprocal of cosine, and cosine is positive. So once again, we're looking at quadrant 4. I don't know why I'm picking on quadrant 4 tonight, but that's kind of where we are. All right, so what we want then is cosine and cosecant. All right, well, cosine, we could do all 6 of them if we wanted to, but cosine, you remember, is 1 over secant. So if the secant is 4 over 1, then the cosine is going to be 1 over 4. And since we're in the fourth quadrant, that's going to be positive. That's going to be positive. Okay, so now we have cosine. We need cosecant. Well, we probably need a triangle because we need the third side. We know that the cosine is 1 over 4, so we need this side over here. And since it's a leg and not the hypotenuse, it's going to be 4 squared minus 1 squared, which is the square root of 15. All right, so cosecant is a reciprocal of sine. Sine theta is square root of 15 over 4, but we're in the fourth quadrant where sine is negative. So the cosecant of theta is going to be negative 4 over the square root of 15. Now if we rationalize that, that would be negative 4 square root of 15 over 15. And that would be our final answer. All right, so once again, it's taking what we know and applying it in a new way. So we're looking at angles in different quadrants, but we're still making right triangles. We're still using the reciprocal functions, and then we're using all of what we know to come up with these answers. So be sure and write down these problems. If you have any questions, please bring them to class, and we will go over them.